You can have them. That's what John talked yesterday.
Oh, but well, let's say again, you're waiting for resources. Are you waiting for EPA resources?
No.
Are you waiting for Amazon?
Amazon.
So that's why I was asking. So any idea how many CPUs
They have.
that they have?
I have no idea, but they're huge.
I mean, if they were huge numbers, I'm surprised that you have to wait that long to get 32.
Yeah.
That's all. So then everybody is computing today.
Excellent.
Okay.
Yeah, excellent.
So when the model actually runs, do you see anything or you don't see anything?
First, you see something here. Just tell you it's running at the time it's going. You can also check your output files. They create a file. There are a lot of ways you can do it. But you will send me an email.
When it's done?
Yeah, when it's submitted. Normally, but I'm not sure it does today.
Install all the cores. That's why I was surprised that
Yeah,
that's like saying how many courses.
That's yeah.
But everybody in the world, maybe Donald Trump did something. Everybody's
yeah.
computation.
So we are supposed to launch or where we want to. That's the things I think we can make a decision together. Or if we want to do something this afternoon, or we just this the end of the workshop. If anyone interested to go further, we can we available. We will be available. But some of you might be need a long way drive back. So this is up to you.
Well, we have right now the same Carl's code.
No, sorry. I'm sorry. I didn't.
Will you be putting up the parallel version of this as well and making that available, or just right now we just have the?
These are things. The code are exactly the same. So basically, you don't need to worry. But
so the code stays the same.
Yeah.
But I was looking at those. I guess what do you call it? Mod files.
Yeah, I will do that. I will the whole the package here, the full package. I will upload it on our web page.
Okay.
Yeah, I will call it the 35K.
All right, you're going to upload the full file
Yeah.
package that you just showed us
Yeah,
on the machine with all the make files.
yeah, everything. Yeah.
Okay, but the source in that is the same
Is the
as the
same.
Yeah.
sources we have.
Yeah.
that we have.
Yeah.
Yep, correct.
Yeah.
And the only modification that we have to make to the source in order to run the parallelization
Yeah.
is in the modules, run modules.
Yeah,
Right,
that.
Where you change it to the right number of CPUs.
Excellent.
No, but we don't have the modules file yet.
No, you do.
Oh, we do have the modules.
Yeah, that's in the
Okay.
source code.
That's in the source code as well. Okay.
Right, but we also need
MTIS or whatever it's
we
called.
also need
Metis.
post-processor, pre-processor.
Right.
We also need the make files and all of the other stuff that he's got.
Right. Okay.
It started running, but I think I would have.
Oh, you're looking for your email list.
Yeah, that if I did not lie with him, this message is sent to me. Basically, he said, okay, the job started. You wait 3 minutes to find the resources. That's what we did. It's not too bad. I think it's 3 minutes is fine.
We're all used to getting everything in.
Yeah, now it's running, and once done, to resend me another email. The job is done. Use how long time? I think about 20, 30. Yeah, I think it's 20, 30 minutes.
Really?
Yeah, it's a pretty fast, but for us, waiting 20, 30 minutes is long.
So, when John talked about this on Monday, or on Tuesday, do you get charged for Amazon searching for the resources to run your job? Or is it when runtime starts?
No. Actually, sorry. I think Gopal confirmed that he just shake his head now. It's actually you use it.
Okay.
Yeah, that's a very good question. But the searching part basically is done by your master node. You paired already. That's the things that, that's very, very good. I think if you remember what John told us, there is one option you pay the computation node ahead. You reserve your car. In that case, we don't need to wait the 3 minutes. Probably you get it, but you have to pay it in advance. You pay in advance, you pay a lower price per hour. That's what he's trying to say. So if we can know, we always use the 2 nodes, we can pay the 2 nodes in advance, then save your time and money. But if you reserve a tool, you never use it, you waste money. Yeah. That's the things that he's trying to tell. Are you sure you want to what? I'm not sure. Oh, I'm sure. So yeah, and basically we have to wait 20 minutes to get the decomposition, and I kind of sort this, and I think I have the result combined, so that we can start looking the post-processing while it's running. I use my old result.
After everything's all put back together again, and it's probably maybe a question more for Carl, your post-processing tools that make the plots, time series, and everything else, do you use commercial software, or is everything sort of constructed for this project?
We use the plotting. We have to write the program that takes the APL file and processes it. And I forget what program we use now. It's a really popular one. But no, the plotting program itself is some commercial program.
Oh, it is a commercial. Okay.
Yeah, it's nothing proprietary or nothing.
So all you're doing is taking that crazy grid and mapping it into a corners file so that everybody knows where to plot things. Yeah. And the time series, you still have to know what segment you want to pull out if you're doing a time series plot rather than a contour, and then pull in the appropriate data. So is that also a commercial? That's commercial as well? Okay.
And I don't know why I can't. I guess I'm a little worn out. I don't know why I can't think of it, but it's just a standard. It's nothing fancy.
And that mapping is essentially really has been done by the hydrodynamic team, right? I mean, that's the same issues we face. Fortunately, that's the nice thing about being a quality model. We don't have to worry about that. At least I look at it that way.
The post-processing, I think you can do whatever you want, right? You use the commercial like GIS mapping, you can do it. Okay.
How do we combine the results?
How
do we combine the results from different CPUs?
Combine just you have to use one. Combine?
Use what? WQPP and the PP.
Oh, a very good question. Because when we got the result, I will show you how, but probably we do not have the time. That's a good question. I will show you how.
What would you type? When you type WQMM, you just got to know whether it's doing decomposition or putting it back together.
That's I think like a.
He had a flag prep.
Prep. That's right.
Exactly. That's the things. I will show you immediately to be clear. This is the post-processing. Okay. So when it's done, we run this one, how to combine. All this, just forget this, okay? Is when, but you just, this is your question, I think, is exactly the same, but you have to...
And it's post versus...
Exactly, post, then the number must be the same as you...
So it has to know how many CPUs were used to put it back together.
Exactly. We can look a little bit. That's what I'm trying to do. Is trying to say that the post, like a mapping, time series, you can use anything, MATLAB or Python, whatever you are familiar with. You can do, anything you use the tool, And personally, I use a lot of GRI doing mapping, doing plot. But yesterday we just use Excel, look at. So this is not, you can do anything you need. But the only thing is that you have to be able to read out, right? Because the output of the files are binary. It not allow you to look at. So here I just show you one program that Carl did. Carl did this typically when he did the calibration. He compared the observation with the modeled result over a lot of stations. This program basically does that. So here is that it read these files to remember the AP files. Okay, this one now is empty because I just remove it. If you look at this. If it's red, it seems you can look. Instead of looking for the APL in the 32 folder, but the job is not done yet, right? We do not have the result yet. But we have one version that we did. Yeah, I want to link it to somewhere else that I just found it. We just use a single CPU result. I think it's there, here, right? This result that we did, and it's exactly the same. We just link it to this one, huh? This one. Oh, sorry. Oh, good. Excellent. Excellent. APL basically is the file that we look at the most, which contain all the variable, including both sediment and water column, that the same as the 30-box model that I read out everything. But the only thing is that it contain only the daily average. There's the PLT files, it's the instantaneous value, but it's similar. So we just do this.
I'm sorry, what's the -s?
Oh, this link, symbolic link. You just link to. Yeah.
What LN is? What's
Yeah.
the -s play?
It's a symbolic. You don't. Yeah.
Oh, it's a hard link.
Yeah.
Oh, it's
Just a symbol, directed to. This file, in fact, does not exist, but just this one. Just this one. Just link to that, with a symbol, basically. You can call this one anything you want, But this the post-processing program Carl did, read. So we can look at this. This is the program. It's kind of pretty. Yeah. This because Sanyang River starts from there. Basically, this is the program. And what it does, I just show you a little bit. This map files, we just did where, what's, so we don't need to, I just want to show you a little bit here. Yeah, this part is really the reading code. And here, the PLTI, basically, we open the APL file.
That's hardwired.
Yeah. That's why you have to have that name. And basically here just read the title, number of variable you did. This is the header basically, the ratio, element ratio between carbon and nitrogen, phosphorus. Yeah. This kind is new. I think this is what is the waterland cover or wet or something.
It has to do with the filter feeders. It's how much of a model cell is occupied by filter feeders.
Yeah, okay, yeah. So basically,
Those are the oysters, really, right? Okay.
This is the header. The real things is started here. Let's see, it started here not? Probably started here. This still, no, this is not. This is something else. The real reading of time series is started from here, the 10,000. This is the number of indicator, basically. You go back there. And basically, I think, Carl, you showed us here, first the time, the day, also see this variable in the code, basically see from 1 to 36.
So those are the That's the parameters.
Yeah, this is a variable like nitrogen, phosphorus, but actually it's not. We did not do every one among the 36. We did I think 28 or something. So basically this number, this number is in the file. It's just read before we get here. Then just this is a major reading. Others depending on what option you did. You want to diagnose this number, I think Carl talked about already.
Somewhere you have to tell it. Let's say I want to do the Lower Potomac. That's LE2, surfaces, 4 boxes.
Okay.
Now I want to do a specific station.
Okay.
I tell it that the region includes exactly 1 box and it's 1 deep.
Okay.
So it'll do a station effectively by you telling it I just want to do a region that contains only 1 cell and 1 layer.
Okay.
So
So these, you're right, I didn't notice that it's like Tidal Fresh 55, is that a specific station?
That's a station.
It is a station, okay.
So we just go a quick look, this was basically the DO concentration on the bottom at the station 5.2, basically the main stem. And I did not select number 4 is the best, where hypoxia happens the most. But I think we have a station 4.2C is a C is supposed to be the center, but a little bit the depth of things is limited. So maybe this one is deeper. Just quick look. We don't need to plot today because it's the same. Basically, this is the time. This is not very deep neither. Basically, the number 3. This is a DO concentration, basically.
So in this particular case, the surface station, the model segment, right? The model that corresponds closely to the right depth is in level 3. Is that what that's sort of suggesting in level 3 at the top? If we go back up again, Richard?
I think level 3 is the bottom, but anyway.
Because you got to worry about how many segments are in there. Okay, so this may be a bottom cell. Okay. Oh, you're right. You did pick bottom. Sorry.
Yeah, and that's the things I want to probably the last message I want to say that this program. Once you have this program, you can do anything you want because it allows you to read out the result systematically. You want to do a map, you just output systematically for each cells. I think Xiaoting did quite well. Basically, she received this program quite similar. She was able to map in the deep layer, top layer, whatever, And once you have this, you just output the things you need, which variable, which depth, you're mapping over one station, so you're fine.
So the surface is easy because that's always level 1. If you wanted to get the bottom, you have to sort of bounce around depending on what the local depth is.
Exactly. Depth also, I think, essentially the cell numbers, which cell number.
Well, the same numbers, but the level numbers.
Exactly. Two. Excellent. We kind of, I think, basically we did everything, unless, kind of it's not necessary. The exercise we did for the 30 box is the same. So it's basically, I think we go through everything. And I'm thinking that the round almost done, maybe we get the result, but, it's the same. So it's the same result. I think, it's that's the recipe of the day.
I think Richard's saying unless there are questions, it's time for caffeine and sugar or
And I have one last question if mine is for Carl. So you had mentioned we got rid of the other filter feeders like Rangia and whatever else that we used to have in there.
No, they're still in there.
Oh, they are in there. I thought you said you got rid of the suspension feeders because they weren't doing anything.
Right.
And you replace them with oysters. And is that because the oyster filtration rates are faster than the other species?
No, let me back up from it. Jim, we had what I'm going to call benthic inflow. Well, I guess we had filter feeders and there was something else.
Well, there was deposit feeders and
Deposit
suspension.
feeders I took out.
Yeah, but you essentially you took out the deposit feeders. Oh, so
Right.
the filter feeders are still in.
And, you know, the
Oh, okay.
3, whatever they were, we have oysters, we have reindeer, and I
And
forget.
whoever else,
Yeah.
whatever else is in. Okay, so it's just the deposit feeders that are out.
Because they
Sorry.
didn't do any, you know, they had no
They weren't really
function.
doing, right.
That's what I
Because all they
meant.
would have done is done something in sediment and excreted it again.
Yeah, exactly,
Okay.
exactly.
Lunch is here today, Gary, or
What's that?
lunch?
Yeah, it's here.
It's there. Okay. There was a very, kind of interesting suggestion yesterday, is that we do a photo before the building together. I don't know, GoPro or Isabel, can you do that? Yeah. And just before lunch, we just do the photo, then, take your lunch and, those who want to leave, just leave. Someone wants to stay, just stay. We stay here until the last one. Okay.
Well, Bill, probably gonna have to find somebody in the street to take a picture so that you're in it.
Isabella is very good. I mean, there's, yeah.
Get the TAs.